Hello, and welcome to your AP Physics Summer Assignment. And I'm going to move this up here so it's a little easier for us to get in there and take some notes. But all of you should have received in your OneNote Chapter 1. I'll show you that really quick. This is what you should be seeing, and I'll quick take a look at Emma. In her Chapter 1 intro, she should have a spot where there's Chapter 1 notes, dimensional analysis, some worksheets and stuff we're going to be working on as we go through this summer. The goal is that I'm going to be making this video, which will deal with the first half of Chapter 1, and then I'll make a second video dealing with the second half of Chapter 1. This first video is going to be on the stuff that we've already discussed, talked a lot about already in Regents, and stuff you probably already know. So it's going to be really boring, that kind of thing. I encourage you to go ahead and take notes along with this. So inside your OneNote, you're going to have your Chapter 1 notes. Go ahead and take notes on this. But let's just jump right in, and you'll find these notes. I'm going to be taking notes in my teacher section rather than in the content library, so I don't have to clean that all up later. But in Chapter 1, it's just an introduction to physics. And just an overview, it is the most basic of all sciences. You heard me say it last year or the year before in Regents. It's considered to be the mother of science, as in all other areas of study, okay, are related back to it. Okay, and it's also described as exploration of the world around us by using mathematics. Now, we talked about this before. Mathematics is the language of physics. And so we're going to be doing a lot with algebra, okay, but we're also going to be introducing the calculus. Now, for those of you that are in calc, it's going to pair up really nicely. For the most part, we'll be doing stuff right along with your calculus class. Okay, there are a few things we'll jump ahead, and maybe I'll give you the introduction to. Other things you may get in calculus before you actually use it in physics, but that's okay. Now, there are two sections of physics. Classical, which has 7 subsections: motion, fluids, heat, light, sound, electricity, and magnetism. And we're going to focus ours just on motion. Okay, that's all. The AP Physics C Mechanics is just all on motion. Okay, other ones you can get in later. Okay, and if we took AP C, E, and M, you'd get a lot of the E and M along with some fluids and stuff like that. But for the most part, we're just going to focus on the motion. And then modern, which we touched a little bit on in Regents, but won't talk about it all in this class. Now, the SI system, just like with all their science classes, just like we did last year or 2 years ago in physics, we're using the System International measurement, okay, where the length is measured in meters, time is seconds, mass kilogram, and then all the other ones, okay, we talked about as the MKS system, meters, kilograms, and seconds. Some was referred to as the KMS system, but, that gets into a whole other thing. Really quick, talk again about the meter, originally defined to be 1/10,000th of the distance from the equator to the North Pole. It's accurately defined as the distance traveled by light in the 1/299,792,450th of a second. Okay, so really, remember, light travels really gosh darn fast. And remember, the symbol for meter is the lowercase m. Okay, the unit of mass is the kilogram. And remember, this is the one weird one. This is the one that actually has an SI prefix. Okay, and remember, it's also very, very important not to interfere or not to exchange weight and mass. Okay, remember, weight is the force due to gravity. Mass is the amount of substance. Okay, or more accurately, another way to measure it too is the inertia, okay, of an object. We'll get rid of this. The second is the SI standard of time, originally defined as to be 1/86,400th of an average solar day. Remember, that's the number of seconds in an actual day. Defined as this, you don't have to know that. And remember, the symbol is the lowercase s. Now again, key thing, we talked about this, we preach this in Regents. Units. Units are crazy important. The reason for that is that without units, measurements are worthless. In order to make a measurement valid, we have to have something to compare it to, from miles, meters, seconds, pounds, okay? And we were really going to hammer home this year. If your answer is supposed to have a unit on it, okay, and it doesn't, we're not going to be taking off like before. We're like, oh, hey, don't forget your units, that kind of thing. We're just going to flat out call it wrong because we've got to really, really get that whole unit thing in there. Remember, in physics, we deal with the very big and the very small. You should be very relatively familiar with the SI system of metric prefixes. Mega is a million, deci is tenth, all these other ones. All of these are also given to you on your reference tables. And you can find a copy of the reference tables. They aren't just, reference. tables. And you can find a copy of this in your content library. Okay, it'll be sitting there into extra information, and I'm also be giving you a hard copy your first day of class. Okay, we won't need to know those for our first part for our summer assignment. You will, but you're going to have a good idea what they are anyways. They're different than our Regents ones. We'll show some similarities and some differences, and we'll talk about those. Real quick, one of the things we didn't talk about much about in Regents, but we're going to deal with here is density. Remember, the density is defined as the mass per unit volume. And now, I just want to point this out. I'm going to zoom in on this. We now have a new symbol for density. You may remember density from before as being D is equal to mass over volume. So D equals M over V. We're going to use the Greek letter rho. This is the Greek letter rho. It kind of looks like a scripty P. Okay. Don't confuse it with the regular P for momentum or capital P for power. Okay, it is the Greek letter, and you're going to be using a lot of Greek letters in this class, so we'll get used to those as well. And then that is also on your reference table. Another thing we're going to introduce, which we briefly talked about when we talked about our modern section before in Regents, was the atomic mass and the atomic mass unit. And again, some of the things we're going to be dealing with are really, really crazy small in mass-wise. So we use a unit of convenience rather than the kilogram. The kilogram is still our SI unit of mass. We'll use a unit of convenience called the atomic mass unit. And it's equal to this 1.66 blah, 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 times 10 to the negative 27th kilograms. And again, if we're dealing with protons, neutrons, and electrons, it's often easier to write their mass in terms of this unified atomic mass unit rather than all the way out, okay, because you have to carry so many decimal places. Now, we also talked about this last year, dimensional analysis. Okay, the word dimension in physics tells us the type of quantity the number represents. And when we talk about the type of quantity, we're talking about length, okay, or time, or mass, or something like that. So it's actually giving us what we're describing. Okay, if we're talking about velocity, that's a unit of length divided by unit of time. Okay, it's a very important concept to learn. It's going to allow you to determine if your method of finding the answer is correct. It's also going to allow you to solve problems without knowing the equation. And the dimensions units can be treated as algebraic quantities. So whatever we do to the number, and again, I'm going to write this down because this is crucial. Remember, whatever you do to the numbers, you do to the units. And that's kind of like the number one rule, and I think I actually wrote this down on the next slide too. Okay, yeah, right down there as well. To do dimension analysis, more important to us to always write your units, and then whatever algebra you do on your numbers, you do on the units as well, and that'll determine the units of your answer. Okay, or by knowing the units of your answer, you can determine the method for finding it. Okay, we're also going to talk about unit conversion. We're going to use dimensional analysis to do unit conversions. For simple conversions, a ratio method can be used. Okay. For more complex conversions, we're going to use a conversion factor multiplied by 1 method. Now, both of those we talked about last year, and I'm going to do a quick example of those. So, like, let's say I just want to convert, let's say 100 centimeters, and I want to convert that into meters. Now, if I do the ratio method, what I can do is say, all right, well, I know one of the things they tell me, or one of the things I remember, is that in their 100 centimeters, and I chose this kind of by accident, in E is equal to 1 meter. And so that almost makes it too easy. So this would be easy. That'd be going to be 1 meter. Let me go with another one. In the fact that let's say that I've got 68 centimeters and I want to convert that into meters. Okay, so again, I know that 100 centimeters is equal to 1 meter. Now the ratio method, which is okay, and I've used this and I've taught this before, but it has its failings. What I'll do is I'll go question mark meters in 68 centimeters. That's a ratio, meters to centimeters. And then I set up the same ratio here, that there's 1 meter in 100 centimeters. And once I get this, now what I can do is I can cross multiply this. And so if I cross multiply, I get 68, and actually I'll just do it all the way out. So I've got question mark meters is equal to 68 centimeters times 1 meter divided by 100 centimeters. Now when I do that, my centimeters cross out, and it leaves me with 68 times 1 meter divided by 100, which will give me an answer of 0.68 meters. And so this ratio method right here, and I'll highlight it, this part right here, we're just setting up a ratio, similar ratios, meters to centimeters, meters to centimeters. Now, the way that I taught you last year, that I really kind of preached, was the multiply by 1 method. Because remember, if you multiply anything by 1, you're going to get the same thing. If you divide anything by itself, it's 1. So, and if I do this again, let's do the exact same thing. Let's say we've got 68 centimeters. Okay, and I happen to know that, remember, that there are 100 centimeters in 1 meter. And so if I do 1 meter divided by 100 centimeters, because these two are equal, they mean the same thing, this is basically equal to 1. And so if I multiply that 68 centimeters times 1, I get to 68 centimeters. So what I'm going to do is I'm going to multiply 1 meter over 100 centimeters. And so I end up getting 68 centimeters times 1 meter over 100 centimeters. And you're like, hey, wait, didn't we just do this? Yes, we did. It's the exact same thing. So now my centimeters kicking out. And once again, now I'm left with that 0.68. Slide this over just a touch. Centimeters. Okay. And we're going to get some practice on this. I have a couple review sheets or a couple worksheets I'm going to have you do just to practice this. And again, I think I put on there, I can show it to you really quick, but I think I put on there in yours, and again, we'll look at Emma's for her dimensional analysis right here. I think I put on there, for this worksheet, do only the odd problems. And I put an answer key below. Okay. And really, once you get the idea and once you're good at it, you're going to be fine, okay? But you want to practice it until you can't get it wrong. Don't just practice it until you get, oh, I got one right, I'm golden. Practice it until you know exactly what you're doing each time, okay? So let me get back to here. And the last thing I'm going to talk about today, almost second to last thing, is order of magnitude estimating. Now, this is something new, okay? An easy way to get a rough idea of your answer to do a problem is by guesstimating, okay? And because we deal with such large numbers, and sometimes it's just easier to punch it all in the calculator, sometimes we get what, you've heard me say it before, the fat finger syndrome, okay, where you put in something wrong. So if you do an order of magnitude estimating, that's going to give you a rough idea of the correct answer. Okay, and so order of magnitude, basically what you're going to do, so let's say you have like 6,800. Okay, 6,800 converts to 6.8 times 10 to the third. And let's say I want to multiply that by, let's say 5,400,000. Okay, that, if I put that in scientific notation, that's going to be 5.4 times 10 to the 6th. Okay. Now, if I were to do an order of magnitude here, what I'm going to do is I want to round this to the 1 to the nearest power of 10. And so my 6.8, this is going to round up. So this is going to give me basically 10. So it would be 1 times 10 to the 4th. Okay, so 10 to the 3rd, or 1 times 10 to the 4th. I could do the same thing here, 5.4 times 10 to the 6th. This is also going to round up. That should be a 5. That's my fault. Bing, there we go. This is also going to be a 5. So this is going to be, we'll round this up. So this should be 1 times 10 to the 7th. Now what I'm going to do here is on the order of magnitude, I'm only going to concern myself with the times 10 to the 4th and the times 10 to the 7th. I'm going to completely ignore the 1. 1 times 1 is going to be 1 anyways, so we don't have to worry about that. So if I do this, and I multiply these two together, what I end up getting is 1 times 10 to the 11th. Now, this is an estimate. So if I were to multiply these two together on an actual calculator, I would expect an answer that's somewhere around times 10 to the 11th. Now, what that allows you to do, that if you can do this in your head, it's going to give you a rough idea, oh, it should be close to times 10 to the 11th. If all of a sudden your calculator spits out and it comes back, oh, times 10 to the negative third, you're like, ooh, I might have typed in something wrong there. We have way too much faith in our ability to use a calculator, and the calculator is always going to give us the right answer. Okay, and seeing how this video is now a lot longer than I anticipated, what we're going to do is we're going to stop here, and I'm going to give you the opportunity to practice some of this. And so for today, when you get an opportunity, go back and take a look and do the dimension analysis worksheet. Again, only the odd problems. Take a look at the order of magnitude worksheet, and then take a look at the solving equations worksheet. This one just allows us to solve for these equations. Again, on this one, only do the odd ones, but this is something we're going to talk about later on, that we want to be able to solve for what we're looking for in algebraically before we put in the numbers. So try these, and the answer key will be either in the content library or listed below, but take a look at those and give them a shot. So have a great day, and I'll see you next time.